we have a couple of new learners today. So I think what we'll do is we'll quickly recap some of the data types that we learned a while ago. So we have a few. Basically, numerical ones, if we talk about it, they're called integers, which is denoted as int. In Java, you have floating points, which are denoted as float, and you have double, which is highly precision decimal numbers as compared to float. Then we have long, which basically carries can capture integral number, but to a very large value. I think it's like few million billion, that kind of big number they can carry. Whereas integers are limited to roughly 2 digits. We also have a smaller number data types like short, which takes 2 bytes in memory, and hence it is limited to 2 raised to the power 16 or roughly 32,000. And then we have byte, which is the basic data type in all the computer science, which stores 1 byte, and it has 8 bits. So the total number of states it can capture is roughly 255 to 6. Yeah. Integers take 4 bytes. Double and long take 8 bytes each. Just for knowledge. So let's start with byte. So let's say byte b equal to 100. So let's start typing and playing with some data types here. So please follow me. Let's create a variable called b of type byte, and we initialize it to the value 100. This is what this statement means. There is also short, as I was saying. So short can take up to 32,000. So let's try 30,000. Right. So short can take up to 30,000, for example. And if you wanted to store higher numbers, you could use int. So int could take, let's say, 12 million. So this underscore is basically another just a like a something called syntactic sugar. It's something that makes reading easy. So we want to set a value of 12 million to I, and we are basically using this underscore facility in Java to make it easy to read. So under the hood, it's just basically 12 million number. Yeah, does not have any string or anything else like that. So these are a few data types that Java gives us, and we will probably be using invariably every time we meet. So let's talk about like a floating point. So this could be 1.2345678, and we have to put a f at the back because to denote that this number is basically a floating point, and this is the value that it stores. Similarly, we can do a double, but this time we don't need to suffix it by a d or anything, because by default, because it's a decimal, it understands that it's a double value. So and don't worry about it because we don't really use float much in day to day. So it's just for your knowledge that you need to put a F if you want to use a float. But typically we don't pay much attention to it. Okay. So I just wanted to know if everybody is able to follow along already, or anybody is facing any trouble. Just trying to declare such numbers and setting some values to them.
Can you explain the f at the end of the float
Yeah,
value again?
sure. So if you look at the double, so double G equal to 1.32234567 works seamlessly, correct? But if I try to do same with the float, let's say F1 to 1.2345678, and if I try to type this command, it fails because the default decimal numbers belong to double, and because double is actually a higher sufficient than float. So but you still want to declare float at all, then you have to tell that this number is a floating point. It's not a double precision. So you have to add a f at the end. Then only this works. Okay. Um. Yeah, it's just like because these numbers look very similar, but they have different meaning in Java. So we need one way to distinguish that decimal is a double precision or a floating point precision. So F basically
Yeah,
helps us.
yeah.
Yeah,
Yeah,
okay.
yeah. Thank you, Manu. Yeah, it is clear. So double means like a real number.
Yeah, both are real numbers, but the precision that the computer can handle. Floating point also takes 4 bytes, and double takes 8 bytes. So double can like be much more precise as compared to float. That's why we prefer double. And floating point F, yeah, floats are not really practically used in day-to-day life.
Okay, sure.
Okay,
Noted. Thank you.
right now let's try to use a um, long type. So let's see what can be an interesting number. Let's try the speed of light. Speed of light is 300 minutes, or is it more than that? I forgot. Let's keep it 3 billion. Yeah, 3 billion is some number, and we get an error. Because similar to floating point, we have to specify that this number is the type long. Then only the compiler considers it as a long. That's why we need a L at the back. Otherwise, it thinks this number is an integer. This number is an integer, and it thinks it's too large to be an integer. That's why this statement gave an error, because it defaults it to an integer constant, and integer constants cannot go much more than 2 billion. Yeah. So yeah, similar concept. We need to distinguish. So here the numbers default, integer numbers default to int type, and if you want to use longs, then you have to denote the constant with an L, so that it becomes obvious to the Java compiler or Java runtime that we're talking about really big numbers or really long numbers. Yeah. Let's take it for a spin. We could, for example, have a much longer number. Let's say 450 into 450. So yeah, which is how many zeros? It should have 10 zeros, isn't it? One, two, three, four. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So long numbers can be really long. It can go up to like a million billion. So in fact, why don't we do that? Let's try long, really long. Let's set a variable equal to long dot max value. So there is some shortcuts available, rather easy to read uh, available information available. For example, this is the max value a long variable can take for long dot max value, and it is basically where you know it's so long. Similarly, you can have a min value also, and the min value is almost the same with the negative sign, because one bit is stored for the sign itself. So out of the 64 bits, because this is 8 bytes, which means 64 bits, 63 bits are available to capture the number, and one bit for the sign. Let's do one quick calculation using a scientific calculator. I don't know how to do it. Let's do, I don't know how to. Okay, never mind. We'll use our old Excel sheet. All right. So let's say 63 bits. So what is the power of 2? 2 raised to the power 63. Okay, this is giving us interesting number. Let's have I put like this. Let's have to format it. Number. Okay. Yeah. Okay. So if you see, this is the number that 63 bits can carry. Let's compare it with this one. 922.33720.36854.780. Java basically ends at 775. So looks like Excel has more capabilities. Yeah, I think Java has a slightly less than Excel, but at least the order is same. It's like a million billion kind of a scale. Yeah. So why the exact number is different than Excel, I'll probably do some research and let you know if you're interested. But yeah, that's roughly how long the really long numbers are. Okay, let's do an exercise. As you see, I have used something called long.min value, long.max value. So it so happens that we have some helper classes for each data type. So for example, we have byte.min value also. Similarly, we should have short.max value. So each of the data types has a helper class. For example, long has a long with a capital N, which is considered a class. Similarly, double has a double helper class. And it has something called max value. And it can go very high. Looks like it can go pretty high. Right. So yeah. So let's do one exercise. Can you type out and play with these numbers a little bit? Like assign a variable double dot min value and share with me what does it show you. So HK, you do double dot min value, and DP, maybe you can do integer dot min value. And then,
Yeah, I have already done that. Yeah.
Okay, please place it on chat, integer min value.
It's minus 21474.
Correct. So in fact, why don't you paste your command and the output both on the chat if possible.
Sure,
Sorry,
sure.
for me it is double value of.
Doubles minimum value of the double type. Yeah.
Oh, okay.
Hi Tapinder, we are just going through the data types and basically playing with the minimum maximum values.
Okay. Hello, everyone.
Right. And so Dipti has shared the minimum value for number, which is minus 2 billion and a bit. Yeah. So that's just quickly check with Excel. If Excel agrees, I guess it will not 100% agree, but let's try it anyway. So 32, 31 bits, 60, and 648. Yeah, it's nothing at integer at least. So integer takes 4 bytes, which resolves to 32 bits, and we subtract 1 bit for sign, plus or minus. So we end up with 31 bits. And as you see on Excel sheet, uh, if we raise 2 raised to power 31, the result is 2147,483,648, which that is GPU's output for the negative number, and the positive number is usually one less. So the positive number is something similar. Okay, so let's try to, yeah, it's basically this minus one. That's how the positive number maximum value is derived. This is the minimum value. Integer value and this is integer dot max. So if in your programs when you write, if you really need a like a small value, a really small value or a really big value, these are the these are something that we should be using instead of putting minus 10 million or plus 10 million. This is probably much more understandable and easy to read and is flexible. So that the platform if capabilities change, this will automatically change to reflect the maximum and minimum in future releases. Yeah, so that's why we should use these if you're looking for a really low or a it's like similar to minus infinity, maximum infinity. Yeah, some program logic work like that. So you can use this as a in those cases. And this one is basically for long. This one is for let's try to do it two bits. Yeah. So long we found the number that we come up with in Excel is slightly different than the number we come up in Java JSL. So I think I don't know the exact reason. I think Excel is doing something different than Java. So for long we don't have an exact match, but for integers we have an exact match. Okay. All right. So now I want to do some data type conversion. So we have I, which is already specified as 120 million or something. Let's say I want to put create a short variable, which is 2 bytes, not 4 bytes, and I want to set it as I, same value as this. Anybody can tell me what is the expected output? Will this command work? What is the number in S1? Any comment from anyone? It's okay. There are no bad answers. Yeah, please give it a go.
What is short comment for Manu? It's for
Short. Okay. Short is a short data type, which basically is a number as well, but only uses 2 bytes. So
only 2 bytes.
Yeah, so the minimum maximum value is limited to these numbers. The 2 raised to power 15 is roughly where the limit is. So let's try start. Yeah, so they're basically limited by 15 bits, so the number is quite short. So what I'm trying to ask you is, so if I try to assign an integer value to a short, what happens? There should be an error. Why? Because the information on the right hand side has 4 bytes of information, and by default Java does not assume any rule to convert into 2 bytes. But there is one way. There's another way. It's called downcasting. You can say if you add this kind of construct, this is called casting. Okay. So what I'm saying is, on the right hand side I have an integer, but I'm going to cast it as short. So now Java knows the rule to reduce the amount of information available in I so that it suits short x2, and it will apply that logic and it will come up with some answer. Okay, let's try to implement it. Let's try to do something. So we know that the short is 32767. If I put the integer like that, and if I try to assign my short like this, the value is copied. Fine, no problem happened this time because the information is transferable. The amount of information is transferable. However, let's say if integer was bigger by 1, and if I try to assign short a number which is not possible to fit inside the short memory of 2 bytes, it will basically overflow and wrap it around. So once you reach the maximum, adding 1 to that number takes it to the minimum. That's the bit logic basically. It's similar. You can do this in our maths also. Let's see. So we have, let's try to add some number 1, 2, 3, and let's do 9, 9, 9. If I want to add 1, this becomes this plus this 10, and 10 is what? 0 carry 1. and this becomes 10 also. So this becomes 0, and we get another carry. This becomes 0, and 10, which is again 0, carry 1. So you see, when you add 1 to the maximum number, the next number is 1000. But let's say there is no capacity to capture this extra 1. So what is the result? The end result will be 0. So there's a wraparound happening here also. So something similar happens in the bit operations, and from so the bits. Okay, let's try to look at byte. Yeah, let's do byte, and we will try to quickly explain it also. Byte b equals, let's just, what is byte dot max? Let's use that 127, and let's define a short SB equal to 128. And then when I convert it to a byte, what is the value expected? Anybody can guess? When I convert the short number to byte, it should be wrap around and go to the minimum value, which is minus 127. Sorry, minus 128. Yeah. So let's try to do quickly, similar to the number we did for 999. Let's try to do it for 8 bits. So we have 127. 127 to a short, sorry, byte 127. Byte 127 is what? It is 0, 1, 1, 1, 1. So we have 7 bits which are 1, and the sign bit is 0. So when we do something like this and we add a 1, what happens is this becomes 0, this becomes 0, and we keep carrying on. So there's a carry here, there's a carry here, there's a carry here. This becomes 0, there is a carry here, carry here, carry here. Yeah. So basically what happens is it becomes 1, 0, 0, 0, 0, like that. Okay. So this is byte 128. So the wraparound is happening, and because of that, we end up with a negative value because the sign bit has changed from 0 to 1. This is how it is shown. Okay. All right. Yeah, I think I am not able to explain the 128 value. I'm wondering if all of them can become 1 somehow. Yeah, I think they all should be 1, but I don't remember how to formulate that. So for now, I will trust the Java JSL and understand that this is how the type conversions happen. So if you're downcasting, which means you're going from a higher precision to a low precision, you need to specify this cast, and then Java will apply simple rule for downcast. When you're trying to cast up, so let's say the byte b2 is equal to 101, and if you want to create an integer which is of a similar value of b2, it works. Why? Because we are basically expanding the precision, so there is no casting. So these are some rules about typecasting. Any questions from anyone?
I think casting is a bit new to me. Casting, is it like to another?
From one data type,
like,
yeah, data type to conversion from one data type to another data type.
oh, which is higher up or lower?
Yeah, so it's not the same type basically. So we have a few. We have byte, which is the minimum 8-bit. We have short, 16-bit. We have int, 32-bit. We have float, also 32-bit. Yeah.
Okay, noted. So it's hierarchy based on the these. Okay, thank you.
These are some defined by Java type, and it's available for us to use. So these are the number of bits. So information in a byte is only 8 bits long. It's not too much. It's like up to 128, 127. Short can have much more values. Integer can have 2 billion values. Long can have million, billion values, and so on. So when you're converting, going from lower to higher is easy because there is no calculation needed. It's just adding extra zeros on the left hand side. But when you're going from high to low, then you need to lose some information, and this is how we tell it to lose information. It's acceptable to lose information. So that's the casting, and this is basically downcasting. Okay. I want to share one more, which is a special type called car. Car is used for holding characters like A or A. But under the hood, cars are also numbered. Okay. So they are, I could do short S equal to C. Oh, okay. There's a lofty conversion. So char, I think, maybe taking more bits now. Let's see. Int I equal to, right. So I for short A is 97. In fact, there is something called ASCII table, which we quickly take a look at it. ASCII table. Right. So we do have some table, and if you look at alphabet A, this is the one. Alphabet A corresponds to decimal value 65. Okay. So if my character was capital A and I convert it into integer, we will see number 65. And what does it tell us? Let's say if I have some number, integer I equal to 66. And if I want to cast it into a cat, what should we see? Any guesses? What number should 66 correspond? What character should 66 correspond to?
B.
Correct. So if I run this command, I see a B in the output. So character is also under the hood a numeric type, but it has some more information. Like if you print it out, it will become a character, like in Numeric. And similarly, so if I try to add 55 is my A, if I add 25 to that, I reach 90. Let's try to see what 90 is. 90 is Z. Okay. And now let's try 97. 97 is what? Small a. So if I do the same, I get a A. And if I add 25 because there are 26 characters, then I should end up with a Z. Okay. So this is how you convert characters to numbers and vice versa. So int I equal to C. So I will be 122 because C is equal to Z. Okay. So these are some type conversions we did at low level. All right. Any questions on what we discussed so far?
No one.
Yeah, I think I'm good with this part. So yeah, thank you.
Okay, great. All right. I did want to make a small program, but which means we will shoot our time because the time was until 11 in Singapore. I'm okay with that. Anybody else? Are you okay to spend some more time?
Yes, Manu, I'm fine with that.
Okay.
I'm good.
HK, do you remember any for loop from your last time?
For loop.
I'll try to. I wanted to create a for loop now as an example, but I was wondering if you will be able to follow or not.
Yeah, it's okay. Yeah, we just start. I still need to catch up. So yeah.
Okay, fine. So I'll do one small program. I guess we all will. Yeah, please follow along. Let's do. We create a class called char counter. Okay, let's call this char counter. So it will be a public class. So public class, and it has to be the same name as the file name. So char counter.pan. It will have a public static void method main, which is standard for any Java program, which can be started from command line. Okay, and we'll say that we want string word as the first argument. So we will just use string word equal to argument 0, and then we'll convert the word into character. So how do we do that? We convert the word into an array of characters, which is, let's call it chars equal to word dot to char array, and then we'll create a fault. Let's create a counter. Um, let's create a in array for counters rather counters equal to new 26. So we are basically going to count how many times each character occurred in given word, which is the first argument of this program, and we'll store them all the counts in a integer array which has 26 elements to catering to all 26 characters. Okay. So now we'll run a for loop for int I equal to 0. I is less than. How do we know how long is the word? Or in fact it could be a sentence also, right?
Word dot length.
Yeah, we can do word dot length, which is a function, and we'll iterate over this word. In fact, let me do something. I'll just get rid of this line. Let's reduce the confusion. And we'll say cat c equal to word dot. There's a function called char at in the string. So we'll extract the character of the ith location. So we are traversing through all the characters of the string, of the sentence even, and we're extracting the character. Then we are going to say, let's call it index. So what we want is we want some index which can then be referred to for the counter array. So how to do that? We know that we'll only talk about, let's say, small case. So we know that A is 97. Okay. So what we'll do is we'll say A3 minus 97, or C1 is even, we'll do A. Okay. And this will tell us an index, and then we'll put it in our counter. So counters at index plus plus. So we increase the count which is at the index. So I think I need to maybe I would give a slightly better function. So we're talking about counter array. Counter array will be, let's say, index will be 0, 1, 2, all the way till 20, 25, right? And then let's say the sentence is I am Manu. So we will say, okay, H. In fact, I'll take up all this only. So H is, what is the ASCII value of H? ASCII value of H would be 104. So character we're talking about now is H, which is basically 104. Now H minus a is equal to 7. So when I pass the string I pass h, and then it goes to this one. So this was initially 0, but now we will increase it to 1. This is because we are having a command called index plus 3. Because of that, this becomes 1. Similarly, now we look at I. The sky table says I is equal to 5. So we quickly know that this is going to be 8. So this becomes 1. And so on. So we traverse through all the sentence and we keep increasing this number. Okay. And this is it. In fact, we need to do one more thing. We will say if C is greater than equal to A is less than or equal less than A, or C is greater than Z, then we don't want to count it. We like a full loop it is not in scope, so we will continue the for loop to next character in the sentence. So now we have a typo here. This should be a curly brace. This is matching. Now, what I'm going to do is system.out. This is a simple print command, print line, and reduce a utility called arrays to string counters. So this will print all the counts of the actual print the count of all the characters which are between small a and capital Z only. Okay, this is what this program should do. Let's try to compile it. I guess maybe HK is a bit high level for you, so maybe after we finish the explanation, then I will walk you through again, while others are have already gone through.
Yeah, sure. I'm just copying what you are doing.
Okay, so I've opened another terminal and try to compile this. It could be a typo or two, so we will see. So to compile, we need Java C, and then we have the char file name, which is char counter.java, and it found one issue, arrays dot to string. So it basically does not know what arrays is. So we need to import this helper class. So we'll say import java.util.arrays. So this is something that I want us to try to build into our memory. To remember what these utility classes are, what are the, how do I import them from our memory instead of using. Oh, there's a typo in my spelling. Sorry for that. So this basically this gives us some more time to fix our mistakes, these small mistakes, and just be more careful as we go along. Now, how do we run a compile? Okay, first of all, Java C this time did not report any errors, which means the compilation worked. Let's see the output. Okay, we see a .class file, which means the compilation worked. The timestamp tells us that the compilation is recent. I did a ls minus ltr reverse time order, which means this is the last file, which means this file should have everything inside what was in there in Java file. Yeah? Now, how do we run a compiled file? We just use the class name, and remember this one is looking for an argument. So let's try to run it without any argument. Yeah. Okay, we get an error at line number 9. So if you look at line number 9, it's getting an error here. Why? Because we did not supply any argument. Yeah. So let's do one thing. Let's add some defensive code. If arguments is equal to null, or arguments of length is equal to 0, then we will say this is system.out and then expecting one argument sentence and then we just exit. So system.exit. Well, 1 means something was not okay, 0 means everything was okay. So we use 1. Let's add a definitive check here. Let's do the compilation again, and then try to run the program. Okay, there's no compilation issue this time. And if I run Java without any argument, it gives a meaningful information expecting 1 argument center. Yeah. So that helps us understand the program a bit more, its runtime behavior better if we have such informative information coming out. Now let's give it a sentence. Hi, this is Manu. And let's run it. Okay, so I get some information out, which is not very easy to read. So let's try to improve the outcome also. Yeah? So we'll add a helper function, which helps us print out the counts in a better way. Public void print cars, and that's going to take the counters, integer array, int, and counters, and we'll use another for loop in I equal to 0, I is less than counter dot length. So you notice a difference. Word dot length has a braces. Counters dot length does not have a brace. Brace. So what is the difference? This is a function in the class string. String is the class of which word is the type, is the instance, and there's a function called length. Whereas arrays don't have a function called length, they have an attribute called length. That's why we don't need a parenthesis here. Just wanted to highlight that. Okay, so we have int. Let's call it integer character equal to counter I. And how do we convert it into a car? Anybody? How do I convert this integer into a character?
Car C. Car
Car
IC.
Yeah, equal to
Car of IC.
yeah. So we need to cast it to a car of IC, and then we'll do a nicer print system.out.println. And let's do printf this time. Printf helps us format the output. So let's see if that %c works. Let's say count of this guy is equal to some number, and what is this guy? C, and the number is, oh, actually I made a mistake here, logical mistake. So and we add a percentage and volume. So the mistake is that I itself actually represents the alphabet. Yeah, that's what our logic was, and counter I is basically the count. So that's why I'm saying there was a logical mistake in the program, but now I have fixed it. So what are you doing? We have counters which captured 26 numbers. The first number representing A, second number representing B, and so on. So the I itself, in this case of the for loop, is the first character, which is A. So this itself is enough to find out A, B, C, D. And this tells us the counts of those A, B, C, Ds. Okay. I know I'm going a bit fast, sorry for that. But yeah, I'll take some questions, and if needed, we'll go back and discuss this again. Okay. No compilation error. Let's try to run this. Oh,
You haven't used that function in the main class.
Thanks for that. You can be a good debugger, I guess. And cards, counter. Yep. Oh, we got a error. Right. Because there's another rule, like we have a static method here, which is the default. Main is always static. But from a static method, which is this main, you can't call a non-static method. So print cat also needs to be declared static. Okay. So there was no compilation issue earlier because it's some method which Java thought is useful for the users, for the programmer, so they added it. But when we try to use it inside the main function, you see there is a problem. Okay. All right. Oh, what's going on here? Count of okay. I think we did not. Yeah. Oh, I see. I see. I found the issue actually. I is 0, but what we need to do is we need to add a here. So something similar what we did here, c minus a. Remember here we did c minus a, so here we need to do I plus a. It's a complementary thing. We need to compile again. Compile will work. Let's try to run the program. All right, so this time we have some readable output. It says count of a equal to 1. If I look at this string, yeah, there is only one a. Then count of b is 0, which makes sense because there is no b here. What about this h? There is two h. Is that so? There is one h here, one h here. Okay, good. About I is 1, 2, 3 I. So it looks like it's working accurately. Yep. So this is what I wanted to cover today. A small program which counts small alphabets from a given input. All right. I guess Tapinder and Dipti, do you have any questions on the program?
I'm good.
I'm good. Yeah.
Okay, super. So I think and HK, do you want to ask any question? If yes, then we can let Tapinder and Dipti disconnect and we can continue. And if you want to do some self-study first, then also we can connect later. Let me know, HK, what is your question?
Yeah, I think it's a bit. For me, I still didn't get it yet as of
Okay.
now. So maybe I will copy all of this code. I will try myself and then watch the video.
Okay. So let's do one thing. I think we'll let Deepti and Tapinder go, and I'll try to share all. I'll add more comments so that you can understand this a bit more. Yeah, and I'll explain to them to you one more time, and then you do some self-study after that. Okay.
Yeah,
Thanks,
sure.
everyone.
Okay. Bye, Deepti. Bye, Tapinder. Have a
Thanks,
good
Manu.
weekend.
Thanks a lot.
Bye. Thank you. Bye.
Bye. All right. So HK, so yeah, I think you have to revisit all the videos, but what I'll quickly show is what does this line do? This will basically say you have the Java library code is imported into our program.
Mm.
So this is the way to import the pre-built code into our program. Yeah. Okay.
Yeah.
And then second thing happening here is the code is usually organized into packages and classes. So java.util is the library package. It's like a tool to segregate different packages of code here. Every package and arrays is the library class, right?
Okay.
Okay, and this class starts here must match the name of the remote.java file. This is some convention. Okay. I will share this file with you. Don't worry, you don't have to copy it. Just need to pay attention to understand what's going on.
Okay, sure. Class start here must match the name of the .java file.
Yeah.
So the class, you mean the arrays class?
No. So it's
Oh,
like
the
class.
public class. That
Yeah,
class.
class is like a program. So it's like a container of a program. Yeah.
Okay.
Yeah. To put it simply, today class is equal to a container which has one program that you're interested in. Okay.
Okay, got it. So this must be saved as char counter.java.
Correct. So if you look at the listing here, this is how we started this work. Char counter.java. Right.
Okay.
And this is, if I look at the VI editor, it shows char counter.java, 49 lines, 937 bytes. Yeah, it's telling me some information here about the file. Okay. And how do you compile a file? You say Java C, and then you give the name of the file in the same directory, and this is how you compile a file, Java C. Okay. So let me write it down here. To compile your program has to be in a .java file in a class. Compile your program, use command Java C. Okay. So I'm just adding those comments for your benefit. So when you read it through and practice it, you will get it. Now, if you want to invoke a program from command line, what you need to do, you need to use Java command, the name of the class, and if you need some argument, then you should provide the argument.
Okay.
Right? So this is how I'm passing one argument. Because it's multiple words, I need to use double braces. Yeah. So this is, I compiled using this command. I just put it here. Also, and to run, you need this command. And what happens when you run?
It will input the. I mean, we provide input to the program.
So this main public static void main. This is how Java runtime knows how to start your program. This is the main method. Yeah. This is how to declare main method upon starting the program. Java will look for it. This method. Okay. Called a method or a function.
Yep.
Well, there are quite a few concepts packed into this one program. Okay, and if your program needs some command line argument, then Java will pass them as string array. Okay, as an input to main method.
It's always string. So like number also will be passed as string.
Yeah, everything will pass as string. Then you have to convert the string to the number. Yeah.
Oh, okay.
So I can show you how to convert that. Maybe in the JSL. Yeah, we'll do that. We'll quickly do that JSL thing. Let's try. JSL string s equal to 1, 2, 3. Okay, if I do int I equal to s, doesn't work. Okay. So if I do int I equal to n of s, doesn't work. So the way to do is int I equal to, remember the helper classes?
Yeah.
So you do integer dot parseInt of string, and then it works. So the helper classes are very helpful.
So integer is the helper class.
Yes. So integer dot pass int will convert the string to an. Yeah. However, if you give it something else like hi, you will get a number format accepted. Yeah, which means this is not a number. The input that you give it is not a number. Yeah. So just for the knowledge. Okay. All right. So we did it so far. Now we talk about array. Have you ever worked on an array in any language?
Yeah, a bit with last time I studied Golang.
Okay. So array is basically having multiple elements, and this is how this square bracket is how you understand that this particular variable is an array. Okay. Array will have length. So if the array is not null and it has some length, then it is useful for us. Okay.
Say again. Arrays is null but have length.
No. So in this program, what we want is we want some meaningful information from the command line argument, right? So,
Okay, I got it. It cannot be
yeah.
blank
Yeah, if
input.
it is blank, it doesn't help us. So we have to
Mm.
complain that we're expecting some argument. Yeah.
Yeah.
And we exit the program because we don't know what to do anyway now. Yeah. Okay. Now let's say you are interested only in the first argument. So array is 0 index, which means the first element is at location 0. So we refer to that as, let's say, word, or I should call it sentence. So we change word to sentence. Okay. Right. So my sentence that I'm interested is the first argument. That is what I expect the. So this is what I'm saying. Expecting one argument sentence. So I'm just picking up the first element and renaming it as sentence, and then I work on the sentence during the program. Okay.
Okay.
And in this one, what I'm trying to do is I'm trying to count the occurrence of each character. Yeah, small a to capital Z. So I declare a counter of type int array, and I only need 26 elements, so that's why I declare 26 because there are only 26 alphabets. Yeah. Okay, and then I pick up one character from the sentence using the count this I as an iterator. So I iterate over the sentence. I equal to 0, I get I, H, I equal to 1, I get I, and so on. So I pick up a character one at a time and check that this character is between A and Z. If not, I ignore. Yeah. So let me try to add some more notes. I forgot to add notes here. Check for attributes input from moment. Array start length cannot be zero. So then we tell user that we expect argument exit the program as no argument. Actually, I think I'll simplify this a little bit so it's easier. I'll try to remove this extra condition. Let's see if this compiles. All right. So yeah, arguments cannot be 0.
And then can you explain again why you have 0 after when you declare the string sentence?
Yeah, sure. So when you declare an array has, let's say, two let's say the array is 5 elements, right?
Yeah.
So there is a first argument, second argument, third, and so on, fifth. So most of the programming languages are zero index. The arrays are zero index, which means
0 to 4.
Yeah, 0 to 4. So zeroth location has the first entry. First location will have the second entry, and so on. I mean, it's we can quickly check via some another example. Let's see. So let's say the array is of type byte. Yeah. So 0 index, 1 index, 2 index. And the bytes are, let's say, 45, 56, 77, 23, right? So there are 5 bytes. So in the memory, this is how it will be organized. Okay. Next. This is array layout in memory. Correct. So this is how it works. So if you have 5 bytes to store, you store them like this in the array. And the index that refers to is starting from 0. Okay. So in our case, we have the args array, right? So the string array here. So the 0th location has this like that. This is what happens. And if you supplied some other argument, let's say, and also okay, so I can even do that. Also, okay, and this doesn't make a difference to the program because we are not reusing it. But I can do one quick thing. What I can do is I can enhance this error message, but found this, and we can just try to add arrays dot to of arguments. Let's improve our logic to say array length should be only 1. So if the array length is not equal to 1, not equal, this is how we do not equal to. If the array is not equal to 1, it will give us some different error. So let's try to compile. Try to run this hello Saturday, it works. But if I try to run it with 2 arguments, it gives me an error. Expecting 1 argument, but found this hello Saturday, comma, this is x. Yeah. So just to demonstrate that, yeah, 1 will become this all like that. Okay, array placement, array storage, and so on. It's, I guess, a different topic altogether, but yeah, just because this program uses it, so we can explain it. All right, so it picks up the first argument for counting characters, then
Is there any other data type other than arrays we can use here?
no. So the main function will always have the argument array, right? This is something that we cannot. This line we cannot change. I mean, we can change the name. We can change the name of this guy. It can be.
Yeah, but I mean the data type we are using. So the name is the name is that. But when you define sentence, you define it as a string, and then you put it as arrays data type.
So this is a counter. So counter is always number, isn't it? And, and I need 26 counters. So I do need arrays, probably the most simplest. I could go with the list also. Yeah, that's possible. But array seems to be straightforward once you get comfortable with it.
Okay, sure.
And why it's 26? Because
26 character, is it?
Yeah, capture counts of A to Z, that is 26 small alpha. Okay. This is how I start the counter. Then I iterate over the sentence one character at a time. Okay, so this is our for loop using for loop. For loop has a few things. First of all, typically you have a counter, so that's why like how many iterations you want to do. You count from 0. You count how many. As long as I is less than the sentence length, I want to keep doing this. Yeah. So you basically have a condition called terminal condition. Rather, not right terminal condition, continuing condition. So as long as this is true, I is less than sentence, the for loop will keep executing. And at before the next loop, I want to increase I by 1. So I plus plus increasing by 1. This is how it typically iterate over one by one on any array and this any word like that. Yeah.
Yeah. But if we just want to limit until maybe half of the length, that's possible. And so I think.
Yes, that's possible.
Yeah.
Definitely. I'll quickly show you. So what you can do is you can say length /2. Yeah. Then the condition will remain true until the first half, and then it will become false, and this for loop will break. Okay.
Yeah.
Okay. Now, because char is also under the hood a number, that's why we can do a less than or greater than kind of comparison. Yeah, that's what we did. Check is the character size between small and if not, then skip further processing and go back to pick up and continue with the next character. This is what's happening if this condition is not true. If it's not a small alphabet, then I want to go back to the loop and look at the next character. So continue basically does that. It takes you to the start of the loop. It increments the I, so I becomes I plus 1, and then you come back here basically to the start of the loop.
Okay.
And index is basically indexes locate index in the counter array on which corresponding to this character. See what's happening, and this is basically increment the count in the counter array at the location of character picked up. This is what's happening here. In fact, I should probably put in a new line so it's easier to read. So yeah, having some more comments.
Okay, so index is okay. What is so it's the location of the. Okay, got it. So like A is 1, B is 2. So it's that mean index.
Yeah, correct. So P minus, so character is A, then C A minus A is 0. So that is the first element of the. Yeah, let's do this here now. Yeah. So we have A, B, C. So let's say characters. then index and counter. Yeah. So character A means index is 0, counter is and the counter array, which is counter array is less than 0 also. Then character B means this counter is 0. C minus A is 2. Let's say this. Now let's say we process alphabet B. Then the counters will change. So say, okay, we'll increment this guy. And we don't want to increment this, we don't want to increment that. Okay. So let's say now we encounter C. Then we will increment this guy. And if let's say we got another B, then we will increment this one. So this is how we are basically counting based on the inputs. Yeah. Make sense?
Yep.
All right. This is how we are counting. This is the logic we have implemented. Okay. All right. I think then we finally we end the for loop. Okay. And then we present our finding. Okay. Using a special small method to print counters. This is what happening here, and this is basically small special method to print character count. Okay, using a for loop. And how are we doing? We are again getting the counter. Get count for first array location. Then we are saying convert array location to its meaningful character. And then using printf function, library function, library function, print out the finding for this character. In the end of for loop, all characters address. Yeah, that's it actually. If we compile this, we don't have any compile issue. And if we run this, yeah, looks like it's still working well for us. Saturday S2 is there is one, there's 2L. Yeah, so this is still accurate. Yeah.
Yeah.
Cool. So this is the walkthrough of the whole program. There are a lot of concepts, so yeah, I think it will take the time. But yeah, please do some practice, during the week, so that and do ask any questions if you have.
Yeah, sure. Thank you, Manu.
Thank you, HK, and thank you very much for.
Are you still recording?
Yeah, I can stop now.
Yeah, can you stop?